So we have a pendulum bob of mass 2 kg released from rest at a height of 0.5 meters from the lowest point. So vertical height is given. As it swings through the lowest point, it encounters a horizontal surface with the coefficient of kinetic friction as 0.2. How far does the bob slide on the surface before it comes to rest? What is the total mechanical energy of the system just before the bob hits the surface? So we have a surface. Okay, let me draw the surface over here. And we have a bob that is hanging somewhere over here. And the mass is given. It's to be 2 kg. And the vertical height is also given. It's 2 kg. Height is given, that is 0.5 meters. And it will gain certain energy over here and it reaches to this point. And post that, however it happens, it will start sliding, So here it has a mu k of 0.2. It has friction. So it has some velocity over here, remember? And it comes to rest over here. Sorry, final velocity. So of course there is deceleration over here. And that's what, end of it, we need to find this distance and so on and so forth. So the working. First I'll figure out, I guess, the potential energy. So we are looking at the mechanical energy just before blah 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 blah, that you guys can write. For that I'll figure out potential energy at top or mechanical energy at top. This will be equal to potential energy plus kinetic energy. So this will be equal to just mgh plus 0 as u is 0. Okay. So this says 2 into 10 into 0.5. So this is basically 10 joules. So then from here we can tell that mechanical energy at or just before the lowest point, it hits the surface at the lowest point, right? Should be equal to 10 joules as mechanical energy is conserved. Reason: mechanical energy is conserved in presence of conservative forces only when we have only conservative force actually. So is conserved when we have conservative forces only acting on the object. That's the right statement. Okay, so we know the energy over here, right? Basically we know the kinetic energy, right? From here I can find the velocity, we know the final velocity. We can find the distance in that way also. Again, there are many ways of doing it, so that is one of the way. Or I can talk about work by friction, right? Let me talk about the distance traveled, distance covered. Now we're looking at that. So the work by friction will be equal to the loss in mechanical energy, right guys? This is also one of the ways, because energy has to disappear somewhere. Since friction is a non-conservative force, it will take away the energy in many forms. So mainly it's heat. Okay, so we know the work by friction is equal to loss in mechanical energy. Then the force, the frictional force times the displacement should be equal to, or how much is that? 10 joules. Then the force is how much? Force is, I don't know the force. We know the force, right? Let me calculate the force now. Fk should be equal to mu k into n. Mu k is 0.2, n is 2 into 10. So basically 4. Okay, 4 Newton. So therefore, D will be equal to 10 by 4. That is 2.5 meters. That's it. This is a much simpler way than figuring out velocity and then so on and so forth, right? From velocity, then we can figure out S. Okay, guys. So this is how you use energy to figure out such aspects.